is there's not a lot of extra time up front, because when I set these meetings up, I allowed, I think, an extra 15 minutes before class. And the Yuja app starts recording that right at quarter till. So there's usually about 15 minutes of nothing at the beginning of class if you go back and try to watch the Yuja presentation after I get it published. But the screen recordings don't have all that extra. The other thing I did is I turned the recording into, instead of high definition, I made it standard. Because what was happening is YouTube was taking the recordings and taking forever to process it because it was high def, and it would turn it into low def, standard definition anyway. So,
No.
yeah, sometimes I'll click on the videos and it's kind of grainy, and then other times it's not. So, yeah, kind of weird. So let's see. Let's open up our Mastercam version. Get it going in case we need to access it, which we probably will.
Isn't that supposed to be a version 2020?
My
Because I don't think the one that the home learning edition.
HLE download. I don't know.
Yeah.
I don't know about that because I didn't download it.
Mm.
Did you download it?
I did, and I thought it was a 2020.
Is it 2020?
That's not what I got.
What did you get?
2019, but I already had 2019.
Oh. Well. Yeah.
Mm-hmm.
I don't know what to say about that. That's the link that Aaron Panic is our contact guy at DEPCO, which is the educational center of Mastercam, and he just sent me a link to it. It's kind of a drag because that will expire soon. So
the link?
Technically, well, they had that whole problem with the Mastercam class that Dave Grady was running. Is the home learning edition has expired in the middle of the class.
Oh.
Yeah.
And so they couldn't do anything with it.
Right.
Wow.
Yep. Pretty much. So let me.
Well, I had already purchased a version of my own.
You bought a version of it?
Yeah. When I was working with Mastercam, I bought another book, another Mastercam. Yeah, it's the student version.
I didn't know you could buy it. They usually just kind of give it to you if you ask for it.
Well, it comes with the book.
Oh, okay.
If you buy the book.
Yeah, I got you. Let's see. I'm going to open up I'm going to just go and open it up from my own file, and then I won't have to resave it and copy and paste it. And here it is. So let's go ahead and start screen tiling here. Side by side. And this one. If you're just joining us, today has been the day of technical difficulties for me. First, my speaker wasn't working. And now my mouse wheel is shot to craps. So kind of doing going between my laptop, which I hate, and my mouse wheel. So kind of a review here. There was a mistake in this program that no one caught. Wow, this is doing all my windows like this. It won't let me scroll down. See how I'm like scrolling down and it goes all, and then it just goes up by itself?
No. I don't see anything.
You don't see my screen?
I see a desktop.
You're not seeing my screen?
No.
Can you see me?
I see minimized. Yeah, I can see you.
You need to go.
I see a minimized version.
You need to go to View.
Mm-hmm.
Up here at the top, you got Video, Audio, and View.
Mm-hmm.
And if you click on Share Only, the screen will get bigger.
Uh-huh.
If you click on Share Everything, then you should see the chat and the participants.
I see the chat window, and I see I see your camera.
So when I go to, are you seeing the drawing now?
Nope.
Is anybody else seeing the drawing? Anybody? No one else is seeing my screen.
Blake says no. Sam says no.
So when I click over, so now, right now, you should be seeing my drawing, and you're not.
I'm not. Ethan says no.
Okay.
Dave says the same thing that I said. I see the desktop with a smaller version of. Oh, doing something.
Are you seeing the eternal window now?
I am.
Now are you seeing the drawing?
Now I'm seeing the drawing.
You are seeing the drawing.
I am.
Okay. I don't know what the deal was, but
I don't know. I see the infinity window.
Okay, now we can get to work finally. Sorry about all the technical difficulties here, but it's kind of the world we live in today.
Yeah.
All right, so we are going to go with start off where we left off. I had at least one person went through and programmed this part of the part, this feature of the part. But it seems like there was a problem right here.
I noted that there was no
feed rate.
Somewhere.
But let's see, it's right here, G1, Z0. In fact, I think I called someone else on that out yesterday, maybe Blake, and it's actually my mistake. F, we go caps lock, F.006. Okay. There's still one more mistake in here. What was it? Oh, it's right here. We went, or I, fed into, well, maybe not. I guess we would have, there would be a G0 and a G42 here, and then you would position X right here. Now, some of you did not submit this homework yet. I'm just saying that it's not particularly due, but you will find yourself falling behind if you don't kind of keep up week to week. I'm not sure how I'm going to deal with this bar that keeps sliding back up whenever are you seeing that?
The scroll bar?
Yeah, when I scroll down and I let go of it. Oh, now.
Oh, yeah.
It goes right back up. That's the same thing that was happening to my volume button on my speaker.
Sounds like you got a gremlin.
Yeah, I got a big fat gremlin right now. So
hey, Jolly.
So as long as I hold on to it, it is fine. But the second I wonder if it's this mouse.
Oh, yeah.
I mean, because the mouse is jacked up, but I think it's locked on. Plug the mouse, and yeah, that's what it is, the stinking mouse. Well, that kind of screws me up because I'm not used to really using my laptop thing, but at least we know what it is now.
Yeah.
Just have to roll with it for a couple hours here. Because I have another mouse, but I don't really want to mess with getting it all set up and downloading the drivers and everything. Well, thanks everybody for getting up this morning and coming to school. At least we didn't have to drive anywhere, right?
Right.
One thing I was going to say too is enrollment opens Monday, and they did go ahead, and I mentioned this last week, but they have scheduled my advanced mill class on Saturday and the CNC lathe class on Thursday and Friday. Because what they're trying to do is they're trying to get everything done in 8 weeks. So it'll be, if you're thinking of signing up, I know most of you guys have already had those 2 classes. But it's going to be Thursday night and Friday night from 5 to 10, which is brutal. And then that's for 8 weeks. And then the advanced mill class will go for 10 weeks from 8 to 4:30 with a half an hour lunch. So that's going to be a push on my end for sure. And anyone,
Right.
I'm just letting you know kind of how they're setting that up. So
For next semester, right?
yeah. This summer I'm going to take educational psychology, and next semester I'm taking technical writing. So I'll be done with my associates after this.
Right on.
Yay! Finally, won't get to really walk or anything. But yeah, hey, I'm 54, so it didn't really matter that much to me. So let's kind of review what we did last week, and we'll finish this program up, and we'll move on to polar milling. And if you haven't turned in this first part, I would encourage you to get that done this week. It's not a ton of homework, but we are structured to have 3 hours of lab above and beyond the 2 hours of lecture that we're doing. So it's also going to help you on the final here in 3 weeks. I'm going to hand you a drawing that's going to be fairly complex, almost like this. And you're going to write a program for the final. You'll write a program from scratch and, submit it by 1 o'clock, and then I'll go through and grade it, and that'll be it. That'll be the end of the class. Yeah, that's one of the harder finals is, in my opinion, is the lathe class that I do. And it didn't really, I just kind of drew the part, and so it kind of incorporated everything that we've learned for lathe. So that's a lot. And I will say I'm fairly lenient on grading that because it's a more difficult project, but it really, it stops and makes you think, because a lot of times I'll get a drawing at work and I'll say, what the heck is this? And then after you look at it for a little while, it starts making more sense, and it's not as intimidating the more you look at it. So it's also kind of designed to be kind of a real world experience of being handed a drawing and expected to get the thing programmed. So that'll be our final on the. That will be. Let's see. I got my calendar up. Let's see. Chris Anderson has sent me a picture. I can't see shit. Thanks for that, Chris. Can always count on you guys to shoot sunshine my way.
Yep.
But you guys can see now, right? We got that worked out. Is that correct? Good. Hi, Jalali. Good morning, everybody. Let's get rolling. Already burned.
Am I the only one with a microphone?
That's quite possible. I see Dave's got his turned on and Mike's got his turned on. The way Yuja works is it only usually allows 5 people to have a mic, so even though your mic may be turned on, you may not be able to use it. So if you have any questions, feel free to type it in. I can ask Robert to go ahead and ask the questions, because once I get off this screen, I cannot see the questions. So.
I guess I'm playing secretary.
Yeah. So we came down and we did all our turning features, which is pretty typical for a lathe part. The best way to remove material on a lathe is with the turning, and it's the fastest way. And a lot of times too, there will be options. Say there was a hole in the middle of this part. You would say, well, I could do that with a live turning tool. I don't recommend that. I recommend doing it with a dead center tool, because the dead center tools are going to be quite a bit more rigid. There's going to be quite a bit more horsepower to drive that tool, and you're going to remove the material a lot quicker. Not to mention, if you had to put the part on another lathe and do the milling features with it, which happens a lot, because sometimes the lathe department will be so tied up that they are unable to do the milling features on a part, which to me is kind of ridiculous. But and the milling department is not tied up, the parts will actually go to the milling department for the other features. So You want to do everything you can on the lathe that is a lathe, a standard lathe tooling, and save the live tooling for things you just can't do any other way.
Do they have live tooling out there at Procon?
Oh yeah, yeah. And we just got done, and it was kind of a recorded lecture. We just got done programming a part that really utilized that tooling, and I'll if you're interested in that, there's a recorded lecture on that if you go into the screen recorded classes. It would be the review multi-axis functions and dual lead threads. Should be able to just click. For some reason, it's prompting me to sign in. It usually just takes you right to the video. I'll investigate that after class. But so where did my drawing go? I think I blasted out of it. Dang it. Open it back up. And so we did all our turning features, and we turned on our live tooling, and we pulled out our 1/4" end mill, and we decided that even though the 1/4" end mill was probably not the optimum tool to do this job, because this flat could have been done a little more quickly had we pulled out a 1/2" end mill. That's another thing about live tooling. A lot of times you're limited to how many tools you can actually get in the turret. So even though this is a 1" step all the way back, we stepped it over 100 thousandths at a time, which was actually part of your homework right here, was to add the extra steps. So if you're struggling with that, I haven't heard of anyone struggling with that, but there's still a handful of you guys that haven't really submitted this or for review. But we this 1.622 guess we decided that was clearance. So we Z minus 0.1. No, 2.5 is clearance. So we were at 2.5, Y0, C0, Z.1, M14. I think that's pull out my M code cheat sheet. Is a clamp main spindle. Turn on the RPM. We wrap it to X 1.622, Y 0.891, which is going to be pretty much right in front here, and clearance, not clearance, but it will be. It's just 8.811 times 2 is where we get the 1.622. Let's see, pull this up a little bit. I'm really bummed out that my mouse crapped out on me because I'm having to feel a little bit.
Isn't that going to plunge into the part though?
No, because we're at Z. This Y 0.891. I think we got onto Mastercam and decided that Y 0.891 was a clearance plane on the other side of this part. Oop, we're going to go top. If we analyze the point here, which it won't let me do, but if you see, hide this. If you look down here on my X's and Y's, this point right here is 0.833 on that Y there, if you can see it. So we decided another 1/8 of an inch away from that. I mean, it's close. It might actually not be a great number, but we determined somehow that this Y would be a clearance plane. And so we're kind of on the other side of this. And then so X 1.622 is this line right here from 0, which is pretty much the
center of the part.
It's the 811 times 2.
Right.
And so we feed into, wrap it down to Z minus 0.1, which would be about right here. And then we feed over and then we rapid over to X2.5, which would be the clearance because the part is 2 inches, right? Or 2.250, I'm sorry.
Oh, okay.
Because we started out, we cut it down to 2.1. Let me make this a little smaller. I made it bigger so that I could actually see the little numbers. Yeah, we're at 2.1, so we can assume that the part starts out at 2 1/4. And so the 2.5 would be a clearance plane. Then we wrap it back over to the other side, y.891 and z minus 2.2, and wrap it down to 1.622 again, which is the beginning of this flat. And so your job was to repeat that. So there'll be quite a bit more code. I mean, I would just copy and paste this and insert it till you get down to z minus. Actually, you're going to be 0.875 because we programmed on the center of the cutter. So z minus, if you're told to go z minus 1.0, you'd actually be z minus 1.125 into the part. So we did that because it was going to be easier to program the other side, this side here, which was we did that using Mastercam as kind of a cheater. Yeah. And then we went 180, and we did this kind of trapezoid thing that created. And all we have left to do with the 1/4 inch end mill is to mill this little feature on the side here, which I believe Blake's already done in his program, which did a pretty good job with. So we'll start back in.
Which feature?
Huh?
Which feature?
This little side slot here.
Okay.
Yeah, so we have to determine where our C0 is. Because we remember when we decided to make this actually C0, we were taking into consideration what a pain in the rear it was going to be to calculate these angles from C0. So if you think about it, if this is C0, this is going to be C90. Well, actually, this will be C90 because
one of them is.
Yeah, one of them is. I think when you tell it to go plus, the part will actually rotate clockwise. So if I tell it C90, you would really, I'm thinking you would be seeing this side, and C270 is over here. Because minus 90 would be this direction, counterclockwise. So, first of all, we want to rapid, I'm going to give ourselves a little extra space down here. We want to wrap it out to a clearance plane so we can rotate the part around. So we'll say G0 X 2.250 or 2.5, sorry. 2.250 would be fine, but I like to kind of err on the side of say, hey, what if I walked away and my OD turn had exploded and my insert was gone and I still got this milling cutter in here cutting around the part, or maybe it wore out or something. I want to make sure that it's not going to continue to crash within reason, a reasonable production delay. So I'm going to wrap it out, and at this point I'm going to tell it to wrap it out since I'm in the clearance. And there's, a lot of different ways to do things. I mean, I'm just kind of trying to give you guys an idea of what the basic structure looks like. And, if your program's right and it will cut the part, then I count it right, I might, give a few suggestions or something, but some people might prefer to just wrap it out with one axis. I like both simultaneous axis movement quite a bit, so I'm going to do where I'm going to get this, I'm going to tell it a C move. Now you can tell it an H from here because we're really at 180 right now. So if you tell it H, you have to calculate which direction to go, and also from 180, so you'd be up here, if you wanted to go to here, you would have to say probably C plus 90 minus the 16. So it would be, now, you know, I could be wrong about this too. So we would only know if we were actually cutting it. So 90 minus 16 degrees, to tell it H plus 74. Or let's see, if you were from 180, I'm just going to tell it C 74, because I know that if I went 90 this way, this 90 degree quadrant would be sticking straight up, but I want to go 16 degrees less than that. So I'm going to tell it to go C74 point. Don't forget your decimal point, because it will think C.074. I think decimal place degrees only go to 3 decimals on that. No mic. Yeah, so if you don't have a mic, you'll just have to type in your questions, so it'll work either way. I'm going to say C74. Sorry, I got a little congestion this morning. And then I'm going to take Z to my start point of my slot, because there's no reason not to. I'll wrap it right on over here to wherever I put it, wherever I mentioned it. I'm way more handy with the mouse, kind of slugging my way around here with this. At my first laptop I bought, I actually wore out my mouse pad. I wore a hole in it. And
Really?
Come to find out, you can't replace those. So I stopped using it because I can replace the mouse, right? Where is that dimension? Yeah. I saw it. What we're looking for here is this start point. Here it is, 418. C minus 0.418, or Z minus 0.418. Okay, so that positions us, excuse me, in X, Z, and C. I suppose up here, we better go ahead and tell it Y0, because what's going to happen if we don't is our Y is going to be over here somewhere. And when it comes down to mill that, see what we need, that slot to actually be on center with Y. So if we don't move Y, by the time we roll this around to our tool orientation, it's still going to be off center and going to cut. It's not going to cut it right. So I'm glad I thought of that. So many things you can't prove, and that's one thing I miss about the lab is we go out there and cut it apart and we figure out what we programmed wrong. Because just programming by the seat of our pants like this, you're just bound to make mistakes. I'm going to save this. Alright, this next move is going to be a move that you guys program, because one thing I've seen over the course of running this class is students really forget that our Z movements on this part are based on X diameter, where it is from the diameter of X. So on this drawing, X is let's see, everything, I don't know why it says X. All the slots on this thing are 0.050 deep on this particular slot. Not all the slots. Like this one is I think I have it dimensioned from 0 actually. Yeah, that one's dimensioned from 850. So that's why we went probably 850 times 2, which would be 1.7 on X for that one. So what you'll need to do is say, hey, this is 2.1 minus 0.050 minus 0.050 will be your Z. So I'm going to say Z minus blah blah.
Ethan says, yeah, but engineers programmed by the seat of their pants.
No, engineers just do the drawings. The programmers do the programming. Although, you know, at Honeywell, the engineers do the programming. I'm pretty sure about that. If Dustin was here, he could confirm that, because they don't let you.
I don't think so.
They don't let you program anything at Honeywell.
No, they have dedicated machine programmers.
Oh, that's
I don't think they're engineers.
Gene Geritano is a programmer up there.
He's a programmer.
So this would be a rapid move in Z. Actually needs to be an X. 274 Z minus 0.418. A little trigger happy this morning. Alright, so this is still going to be rapid to the surface. You'll say X, blah, 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 and then you'll say G something, which will turn it into feed mode. And then X. No, this is going to be a center cutting end mill. So you don't have to worry about you drilling in it or anything. So just going 50 thousandths deep, you can just feed in there. Alright. So
right, we can just program on center of the feature.
Yeah, so it's
right.
going to be feeding right down into this at this point. So some older machines, if you look in the book, I'm gonna open this in this because we're gonna actually talk about this some more, or we'll need the book later when we start talking about polar milling. Feed rates can be kind of wonky on the C-axis. Like I've had to, like on the ball bat when we were able to actually engrave it, some of those feed rates are like 999. If the machine's reading degrees per minute, sometimes the feed rates are going to be really high. And it talks about that a little bit in the book here. And some of the older machines, there's a certain M code just to kind of make you aware. I'm glad this is a short time. I was looking at this last night. I should have wrote down the page number. Limitations for fine spindle control. Yeah, it may or may not be this.
It's complicated.
Yeah, it is. So I don't go into it too much because it's kind of based on older machines. So just make your feed rate something normal, you know.
But don't you have to tell the spindle a feed rate as well? So
No,
you have a feed rate for the mill.
No, because the spindle
and then a feed rate for
the spindle is turning. Your spindle is actually the live tooling. So when you tell C, yeah, I guess your question is when you tell.
But it's.
Yeah, so the next move will be a C move. Or it would be an H move, and we'll just have it go off this feed rate. Like I say, some machines that could look like 999. And if that's the case, that means it's reading like, and I'm not 100% sure about this, but it's reading like degrees per minute. So, yeah. Some machines will calculate that for you and turn it into inches per minute. It seems like on the ball bats when it does engraving, so the feed rates are like super kicked up, like 999 degrees per minute, or when it's doing those C and X movements. So we'll just plan on it being like 6 inches a minute or something for the sake of not being sure what that is. All right, so your C move will also be something that you calculate. And it'll just be the difference between 180. So if you tell it C, it would be 90 or so minus this 15. Or 270 minus 15. If you tell it H, it would just be the sweep. So it's basically just going to feed in C axis all across this diameter or this radius. And then.
So it's going from left to right?
Yeah, it's how I've got it. It's going to feed into here,
Mm-hmm.
and then feeding over to C here, and then we're going to feed
Okay.
out on that final little dog ear, for
Right.
lack of a better word. So the next move will be an X move, or a Z move. Sorry, I get myself confused. Those 1, 2, 3, 4 lines are designed to cut this feature all the way
Sam
around.
says that X is a Z move.
So yeah, so it goes X to here, Z minus to here. Then this is a C move all the way across because you're rotating the actual
Mm-hmm.
spindle. Then this will be a Z move. If that makes sense. Is there
Yeah.
any questions about that? That X
Not
move
so
is
far.
moving back. Yes. All right, so now we're done with that tool, and we can, we can think about pulling out some drills and tapping, drills and taps. Now, because of live tooling restrictions and having enough tool turrets, we're not going to center drill these holes. A lot of
Mm-hmm.
times I'll use what you would
Are
call,
we still on the part here?
huh? Yeah, we're still on the part. We need to
With that
work it
last,
out. Yep.
yeah, we need to get out of the part.
Yeah, and so it'd probably be wise to pull up an example of this so that we don't leave any codes out or any order of code. And the problem, let's see, I guess I'll just use my arrows here. And it's looking for an average example of turning off the live tooling and rapiding out. Now, Mastercam will program lathes to use Y and C and X axis movement. And what I've found is that you can use regular milling tool paths seem to work a little better than the actual C axis tool paths that they include in the lathe. And we might, look at that if we have time. Look at what it looks like to program this part for a lathe. Here we go. So this is what we're going to use next. Radial tech drilling. And
Sam says before the second C move, it should be GZF.
for a second,
For the second C move.
So is it this one here you're talking about? This line? GCF, not GXF? No, because,
GZ
okay,
is Z.
here's what I'm thinking. This X, so we're at 2.5 right now. This X, we would wrap it down a little bit closer to like X, 2.2 or something. And then we would say G1 X and then feed into the part in X.
Feed in. Not a feed rate.
You know what? You're right. I need a Z move here. That's what it is. Z. So in other words, Sam was right because we have X rapid, and then we X feed into this.
Gotcha.
And then
we don't have any.
Yeah, this is the
right.
Z.
We're not moving back in Z before we turn.
This is the Z move that Sam rightfully noticed that we left out. Then the C move, then another Z move. Good job. I like it when you guys catch my mistakes.
Good catch.
All right, because I make plenty of them. I'm going to bounce up a little bit. Control save. So pretty much we can, I'm going to go over here and just copy some of these codes. Or we're just going to say G0 X 2.5, which is our clearance plane. and Z.1. And if we had the coolant on, it'd be a good time to turn that off. M9. And for live tooling, I like to kind of go through the motions, turning everything on and off between tools, because if for some reason you just ran one tool path and we're going to maybe go back into skipping around through a program that doesn't have an automatic restart, I kind of like to put everything back in turn mode. And I'm trying to find a good example of that, which is right here, really. So M135 is going to turn off the live tool drive. I wonder if it'll let me copy and paste all this. No. So I'm going to tell it...
no such luck.
Yeah, M135. And we're going to tell it M155, which, looking at my cheat sheet, is C-axis disengage. It's kind of strange to me that it needs all these codes. Newer machines may not need all this. We've already turned off the coolant to be the M9. I'm not going to bother to zero out the C-axis. But what they're doing here with this G0, G28, H0 is it's the same thing as in the mill when you say G0, G28, Z0. It takes it to machine home. And for our applications, there's really no reason to do that right now. And so I'm going to say G128 or G18 to put it back in XZ plane in case we're going to do some turning after this, but we're not. Just a good practice with live tooling is to turn everything off with each tool. I've gotten myself in trouble more than once. So I really believe also that these two can be on the same line, G18 and G99. So that puts it back in XZ plane, and it also puts it back into inches per rev mode. And G28, take the tool home, and then an M1 for optional stop. And I'm going to save this, bounce it up. The next thing we're going to do is call out a 1/4 inch. Let's see, what are we doing here? These are just drilled. These 4 are just drilled. And these 4 are, I believe, drilled and tapped. Let's see here. There's some extra lines there, so I can only assume. Drilled and tapped. Must be in the other view. Nope. Let's see. Oh, tap 1/4 20 by 750 deep, 4 places. So we got 2 different drills to pull out. And probably the best thing to do here is to just kind of copy what they're doing. But we're going to be using this is just on C on center. So we'll use the radial drilling cycle example that they have here where they're actually using Y. I'm going to pause the recording